They're like, well, we gave you a representative sample. And you're like, no, you didn't. You gave me 4 boreholes, one on this side, one on that side, one on that side. You missed the whole middle. That's not my fault. That's your fault. You did a geotechnical investigation.
This is the Contender's Edge podcast, where ideas challenge institutions and underdogs rise to lead in construction. Hosted by Zulq.
Welcome to our edition of Contender's Edge. I'm your host, Zulq Malik. I'm with Smart Build Construction. I'm bringing to you my 30 years of experience in the construction industry. And today I'm being joined by my guest, David. I'm going to say Jasinski.
Yes.
Got it? Perfect. We're going to be talking about when the ground fights you back on a construction project, the benefits of proper geotechnical investigation versus everything else that's being done in the real world. So maybe, David, you can do a quick introduction. Welcome, and tell us a little bit about yourself.
Hello, everyone. Thank you, Zach, for the invitation. Thank you for having me. It's a great pleasure. And to be honest, I'm pretty excited because I think it's my first podcast of this kind that I record in my career. So, yeah.
Awesome.
So my name is David. I'm working for construction industry and civil engineering for more than 10 years. I graduated as a mining and geology engineer. However, that time the mining industry was in a little bit trouble. So I, directed my career into the civil engineering sector. I was working as an assistant driller, geologist engineer at the site. Then I went to the more office works. I was working as a geologist for Tendon department for WeBuild company. That time it was called Salini Impregilo, the biggest Italian construction company. Then I directed myself to more like business developer, sales engineers positions, working for Pietrucha Group, Polish company that is producer of geosynthetics and vinyl sheet pies. Now I'm holding position of engineering director in ESC, still in United States.
Awesome. Well, you've got quite the past, and mining is making a comeback, David. Everyone's trying to look for those critical minerals.
Exactly.
So it's making, and they're all thinking about it's going to be a deep mine. No, these are pretty shallow surface mines.
And very, very interesting ways to exploit those minerals.
Yeah. Well, I guess nobody wants to talk about that. Mining is a one side of it. It's the production of those or the processing of those minerals that's going to be the real challenge. But that could be a topic a whole other day. We're happy to have you here to talk about geotechnical issues. I know that you've worked on some projects where there's some case scenarios. In my background, there's a reason why we created a civil division, because we found there was money in the dirt. And the reason we said there was money in dirt was when someone doesn't do a proper geotechnical investigation at the very start of the project, that's usually the point where you start to incur additional work and additional costs. And at that stage and time, from an owner's perspective, the project, everyone's still happy. They haven't overspent their budget yet. So there's money to be spent. And then later on, when the building starts, they realize that, wow, I spent a lot of money on the ground and I really haven't accomplished anything. All I have is foundations in the ground. That's not a building. That's just foundations at that point in time.
Exactly.
So we found from our experience that, hey, it only makes sense to get involved with the underground portion of the building, with excavation, foundations, and all of that. And there was a common theme. The theme was, we're going to do X number of boreholes on a job site. And somehow the boreholes always missed all the problem areas, right? And they're like, well, we gave you a representative sample. And you're like, no, you didn't. You gave me 4 boreholes, one on this side, one on that side, one on that side. You missed the whole middle. That's not my fault. That's your fault. You did a geotechnical investigation. And I think you've worked on a project in the past where that, like, you guys had an example of doing good geotechnical investigation and what you could do versus we can talk about all the failures. And I think we know what the cause of the failures are. We're going to save a few $1,000s on coring drilling rigs and to get some real samples from the ground.
Yeah, exactly. So one of the examples of one of the best projects I was working on was in the UK, in London. This is my opinion, and you can agree or no, but I think based on what I saw in different parts of the world, UK standards for making the geotechnical investigation report, the methodologies that they use and even money that they invest only on this stage is, comparing to other parts of the world, much higher and of course much better, which reduce the risk for the investor. And the best example of the project that I was working on was like, if you can imagine, existing building, skyscraper, and the investor say that we don't have enough space for the cars for our guests, so we need to figure out how to build new parking levels underneath the existing building, or
Wow.
we're gonna demolish the whole building. We're gonna build much deeper underground construction, and then we're gonna build the skyscraper once again from the scratch. And yeah, during this investigation for the soils, we drilled the holes up to 115 meters, which is about 350 feet, more or less, using very advanced drilling methodologies, and also investigations, in situ investigations, like inflating balloon that has a lot of sensitive devices around and measuring the reaction of the rocks during the pressure dam. So yeah, it was amazing. And I can say that UK experience, it was more than 1 year. I think it was 13 months, but it shaped my career. It shaped how I see the proper geotechnical investigation for the construction site. Comparing to Poland, for example, fortunately, when we talk about the construction projects, they invest around 1% of the whole budget only for geology. I was working in UK on the projects where they invest 10% of the whole budget. So 10 times more. And
Yeah, I guess the
of course,
success was 10 times better.
at the end, you have much lower risk for any troubles afterwards or during the construction.
And I think, we're in a modern era, right? I studied civil engineering. You did mining. A lot of the core courses in engineering are very similar, right?
Mm-hmm.
Strengths of materials, soils, and geotechnical and all of that. But the reality is that when we go and developers invest into a geotechnical investigation, that could be the start or end of their problems without doing proper due diligence. And the technology that exists in 2025 can get you so much more if you're using advanced techniques. And the advanced techniques are not necessarily drilling a hole. It's what you're using for sensors and what you're doing for devices. I mean, there's a whole universe of IoT devices now, the Internet of Things, where we can probably put sensors down while you're drilling and get some of the end values as we're going. I had a presentation at one of the universities here in Toronto, and there's got to be a universe where I don't need to drill a 4-inch core hole anymore. I should be able to drill a pencil hole, and I should be able to have a sensor at the end of the pencil hole, and I should know the end values as I'm going all the way down.
Mm-hmm.
And the problem is, because we're such a mature engineering, there was a resistance for that change. No, this is how we do the standard Proctor value, the end value that everyone looks at a geotechnical report. And I go, yeah, but it's 2020, right? Like, we've got sensors we can deploy autonomous vehicles in space. Why can't we develop the sensor that measure pressure?
Mm-hmm. Mm-hmm.
Right. And
Totally.
so I know that you're seeing some revolutionary stuff happening around the idea of drilling and the sensors and all that. Is there anything you can share with the audience? I mean, I think there's some cool things that you've shared with me, but it's really important that people know that there's cutting edge stuff out there.
So actually, I'm also, let's say, influencer on LinkedIn. I have many different followers on LinkedIn, and a lot of companies, startups, reach out to me with their information they want to share with me, and maybe I will be interested to share their technology to my audience. And one of those companies is Polish startup, and they making a great job. They call it Vidmo. So they invented spectral geopenetration radar, which is a great technology because it gives very accurate results, very close comparing to boreholes. So, in situ test that you need to drill the hole, take the soil sample, and, test it in the laboratory. However, it's gonna give you good results when you're gonna compare those results with boreholes. But thanks to this, you can reduce the number of boreholes. You can make this very quick methodology of spectral geopenetration radar, because what the spectral geopenetration radar is where quickness and speed of the of making this test at the site. The device is not huge. You can basically make the few kilometers of road within 1-2 hours. Comparing this with, and mixing this with the results from normal boreholes drilling, you have the whole cross section of geology with like very high accuracy. I would say 90%, 80% of the accuracy of normal boreholes, comparing to normal penetration radar that works only on one type of waves in a one time. Actual geo-penetration radar emit different length of waves in the same time, and that's why it has this advantage of getting so accurate results. So this is one of the technologies that I came up recently. And yeah, except this, there is many different technologies that we can mention. And the problem in our industry, I think, is, as you said, people are quite reserved for any type of innovations because it works. And we need to remember that we, as engineers, we have a very high level of responsibility, not only for money, but also for the health and life of people. And that's why people are so reserved to make any brave move towards new innovation technologies. And this is the problem, because the responsibility is on them.
Yeah. I mean, they're inherently, I'll say this, most engineers are underpaid for the responsibility that they carry on their shoulders, right? That's number one. We've lost a lot of substantial talent in the universe when it comes to, we lose it to other sectors because they're more innovative, they're more forward, they pay more money. That's what innovation comes from, money.
Yeah.
So they take the brain. So there's a brain drain. But we are, construction as a whole, I want to say that we're not recession proof, but it's a very stable economy in the sense that when the economy is feeling an economic downturn, the governments all pour money into projects, right? And all those projects result into some kind of construction activity. And when the economy is doing good, the economy drives these construction projects because they need more warehouses, more roads, more logistics. They need more of these things. Generally speaking, like, our industry is always moving with the flow of the economy. We just shift what projects are being built.
Yeah.
And nowhere in time, as it is now with AI, with these GPDR technologies that exist, right? That we can intersect all that information and really take informed decisions. But the reality is that there's still hesitancy because and if there's a message I could bring out to the developers, the engineers, all of the above, the reality is this is money well spent. And now you're working with a team of people that you supply construction materials to large scale dig projects.
Yes.
And if somebody doesn't get their job right, somebody's going to make either a lot of money, or it's going to cost someone a lot of money when you got to ship the materials for a job site. I think you and I had a conversation where we were doing a project, very small footprint on a site. They did boreholes. Nobody even went and did the historical study of what this site used to be. Turned out it used to be a garage in like the 30s or the 40s. It was a piece of land donated for some other cause. So the boreholes missed oil that was on the site.
Yeah. This is actually also project in UK, other side. And this actually bad side of the not proper geotechnical investigation. I remember the site that we were drilling boreholes to take the environmental samples in a already built resident also in London. The story of this was investor built a huge residential area for people, and it was I think 10 years before we make our
project
geotechnical surveys there. People moved into this area, and after some time living in this area, they start to feel sick. They had some problems with health. So, and many people start to feel bad, actually ill. So after some investigation, it turns out that the whole area is spoiled and it's contaminated because it was old refinery. And I remember when we start to drill the holes in boreholes with the depth like maybe 1.5 meter depth, we just took the samples full of oil, completely full of oil. And I won't forget this smell. And every day I came back home with the head like this.
Right. There's a lot of off-gassing from petrochemicals.
Imagine the amount of money that this investor lose, probably because he was sued or because this residency couldn't generate the income, and only because he didn't make the proper due diligence. Somebody makes few boreholes in the area, they find probably the geology is okay, is firm, and they decided to build blocks there. It was big problem. However, another story, it was in Scotland, also UK. In history, I think it's on 90s. There was a old cow farm
Yep.
buildings, and one person was infected by anthrax virus.
Okay.
And we, as a company, make these environmental samples. We drill the boreholes. We took the environmental samples to find if there is any trace of anthrax virus in this area, but fortunately not. But I remember it was one of the toughest site that I was working because we had to wear full mask, full PPE costume that will, provide the resistance for any biological virus or other things like this. And yeah, it was very tough because it's not easy to make the physical work in this type of.
Yeah, I mean, the reality is that a lot of the projects that are happening in anything close to a city is considered a brownfield project nowadays.
Mm-hmm,
Depending on where you're living and where you're listening in on, there's a lot of brownfield projects because they happen to be closer to metropolitan cities or they're adjacent to metropolitan cities, and that's where the construction is going to happen.
mm-hmm,
The days of going way out somewhere in the middle of nowhere and build, well, that's a different cost, right? Because now you're going to build the infrastructure to get there and bring the
mm-hmm,
humans back from those locations. So it's very important that whether you're a contractor, and listen, when there's a poor geotechnical investigation, the
mm-hmm.
contractor is a benefactor,
Yeah.
right? If they can manage that exploitation of risk. Because if they understand what the geotechnical report says,
Mm-hmm.
if they've done their due diligence, they know how to comply with the contract. It's a great opportunity as a contractor
Yeah.
because it's
Yeah.
literally start printing money at that point in time.
Exactly.
From an owner's perspective or an engineer's perspective, that's like a nightmare come true because if they don't do anything with it, something happens and the contractor does it.
Mm-hmm.
They have no choice. The project's going to be stalled, right? It can get tied up in litigation. It can get tied up in all kinds of other things. And I think for all the young engineers that are aspiring to get out there and say, hey, I really want to be an engineer and I want to learn best practices, don't rely on minimal amount of information
Mm-hmm.
for something you're going to be responsible for, somebody's going to hold you accountable for. You know
Yeah.
what? There's an element between the bare minimums and far too much. Somewhere in the middle is the meaty part.
Mm-hmm.
And there's some real opportunities. And I think as an engineer, David, you and I, it's beholden on us to tell people, stop creating these same mistakes over and over again. Let's get better
Mm-hmm.
at it. And with the companies that you're participating with and hearing about and sharing with, like, having GPDR technology that's getting better and smarter for companies that don't want to use their technology, you're not helping the industry advance. So that's
Mm-hmm.
problem number one. Number two, that these technologies are giving us different solutions that we never even thought of. So
Mm-hmm.
I think it's beholden on all of us to want to really advance the cause because we could bring some really cool tech to the industry. Like, I want to know why we can't develop a drone that has enough downward force to drill a hole in the field. So when we're looking at these mineral extraction projects, why do we get to clear a path to send a track machine in to drill holes when I can fly in a drone, drop it down, drill, have some sensor technologies? Whoever's listening, if you steal my idea, invite me for dinner at least, but really have the downward pressure so I could drill this hole, extract my sample and get that information and do the analysis in situ, right?
Yeah. We see that some, innovation is coming towards this type of work, this type of, machines. I already saw Durian. I think this is startup from California. They invented autonomous drilling rig, and autonomous drilling rig can serve not only on Earth but also in space. This is another part of the construction. I think everyone is making the test in Earth and everyone is talking about this, but let's see what we can do in a space. And there is more and more startups. Actually, it's quite popular. Also, a lot of startups reach out to me quite recently that they have they are working on some technology that can be used in a future for space exploration, for the minerals or the construction, which is, great.
Yeah, no. There's one last little topic I want to talk about is especially on projects that, you're working in existing areas and
Mm-hmm.
the benefit of GPDR technology. We had a project that we worked on. Every time we stuck a shovel in the ground, we found some new utility service. And I think
Mm-hmm.
some of Widmo, some of their
Yeah.
technology will help them with what they call, ground utility investigation.
Mm-hmm.
for municipalities, you're doing expansion to treatment plants, you're doing all of this stuff. You think you know where the conduits are gone, but in
Yeah.
reality there's probably some poor record keeping that you have no clue where you
Hmm.
found underground utilities, right? So I
Yeah.
think it's important that, people highlight it's not just about the boreholes, there's the GPDR can also help with subsurface utility investigation.
Exactly. And another story from UK. In UK, there is a standard to dig a pit hole up to 1.2 meter, 4 feet deep. That is mandatory to dig. And my God, this is pain in the ass, really, to dig these holes. And I was assistant driller, so I was responsible for doing this.
There's a bigger
For
pain in your ass.
every borehole you need to dig this hole. And if the soil is easy, okay, but sometimes you deal with very hard soil and you dig, centimeter after centimeter, because this literally like a rock. I remember that I was doing this on a old brick factory that was demolished and flattened with the machinery, so we were digging in old bricks, but
Yeah.
we still had to make it because this is the law, the responsibility, insurance, things like this. I was, you dig and you know that you won't find any services, underground utilities there, but yeah, you still need to have it. You still need to make it, because there is no technology available on the market that will give you almost 100% sure or 100% sure that you won't find anything, because normal geopenetration radar is not that
It's
great.
limitations.
So this is big issue, and I believe that innovation in this side, and I really believe Vidmont can be something like this, can cover this problem as well.
Vidmo goes to what depths? I think it says about 5 meters.
So depends of the wave length. I think they are working right now to go even 100 meter below the surface level.
Oh,
Yeah.
wow. That's awesome.
Yeah.
That's awesome.
The current technology allows to go up to, I think, 40, 50 meters, more or less.
And for our American counterparts, 50 meters is roughly 165.
160 feet, exactly.
So that's a substantial depth, especially in urban projects. I mean, I've seen some pictures of it. Hell of a lot more efficient than bringing in a big track-mounted rig to do some investigation.
Exactly.
Awesome. David, thank you so much for having the time to come out and have a chat with us and talk about why when the ground bites you back. Because the reality is if you don't pay attention to the ground, it will hurt you every time.
Yeah, exactly. Yeah.